So we want to talk about green M&Ms. We're going to do one single sample of M&Ms. So we go out, we collect one bag of M&Ms. There are 200 in their total. We find 50 out of 200 are green. We're going to build a 95% confidence interval for all M&Ms based on this one bag. So the first thing we have to do, just like we were doing on test 2, is identify our variable. So who's our population? Remember, population is a group, not a number. We're talking about M&Ms. Which M&Ms are we calling success? Well, since we're talking about green, let's call success green. Then this is what we're trying to figure out. P, the proportion of M&Ms that are green. That's what we're trying to estimate right there. I want to say something like 40% of all M&Ms are green. That's our goal. Okay, so we have a sample. In that sample, there were 50 actual green M&Ms. So X is the number of successes in the sample. It's not a percentage. N is the sample size. Then our success rate is just 50 out of 200. P hat is always X divided by N. So we have a 25% sample success rate. 25% of the sampled M&Ms were green. 75% failed at being green. Okay, we're supposed to check all those conditions. Obviously, if I grabbed myself a bag of Christmas M&Ms that are all red and green, well, then that sample doesn't look like all M&Ms, right? That would be a terrible sample. If there was a problem at the factory and there was something wrong with the sorting machine that made my bag, then this would be a terrible sample. But let's assume that we did our job right. We got a good unbiased bag of M&Ms. Then we should meet our conditions. We're supposed to check those size conditions. You can check them on your own. We meet them. Then we calculate this thing, the standard error, square root of P hat Q hat over N. Again, if you don't know what all the symbols stand for, you're not going to know what to type in here, and you're just going to make a bunch of stuff up. So I get a standard error of about 3%. Then the question says we're doing a 95% confidence interval. So our margin of error is Z star times the standard error. I have to look in that table here and find the right Z star. I recommend writing these three down. If I'm doing 95%, I want 1.96. So 1.96 times the standard error, we get a margin of error of 6%. Then our confidence interval is, that's our plus or minus right there. That's what the sample said. The sample said 25% of M&Ms are green. That's my wiggle room, plus or minus 6%. So I go up and down 6%. Then I write my sentence, and my sentence is we're 95% confident that between 19 and 31% of all M&Ms are green. That's it. That's the entire problem. And this is doing it by hand. Up here in a second, I'm going to show you how to do this on the calculator, and it's even less work than that. Like, the hardest part of this whole thing is making sure you know what all the letters stand for and writing out this sentence. So I want to really emphasize this sentence here. We're building a 95% confidence interval because that's what the question asked for. That does not mean 95% of M&Ms are green. That clearly doesn't make any sense. It doesn't mean 95. If you write a sentence and you say 95% of, you're wrong. Your sentence is wrong. If you put the word of after 95%, you are not interpreting this interval correctly. That's how confident we are. We are 95% confident that we got the right answer. And what is the right answer? That between 19 and 31% of all M&Ms are green. Okay, so what does this 95% really mean? This means if you were to go out and play this game millions and millions of times, you go out and you look at millions of different bags of M&Ms, and every time you build a confidence interval. Well, sometimes you're going to catch inside that interval, you're going to catch the real number, and sometimes you're going to miss. That 95% means 95% of the time you would catch the real number. So let me draw real quick. Someplace is the real number, the actual real number of green M&Ms, the fraction. I'm just going to make up a number. Let's say it's 28%. We don't know what it is, but that's what we're trying to estimate. Let's pretend right now 28% of all M&Ms are green. I just went out and I did a confidence interval, and that confidence interval said 25 right in the middle. That's what the sample told me. And then I had to leave a little wiggle room on there. So I went, I think it was down to 19% and up to 31%. And I said, I'm 95% sure the real answer is someplace between here and here. Now, what if we go out and we do another confidence interval? We go out, we grab a different bag of M&Ms. Maybe that bag would have a success rate of 40% green. And then we'd build an interval around that. And we would say, we're 95% sure the real answer is between, I don't know, maybe 34 and 46%, something like that. And we keep doing this over and over again. 95% of the time, our interval would actually contain the real number, which is what it is we're trying to estimate. So that's what we mean by 95% confidence.